Hi, and welcome to the lecture Performing Feature Engineering to Improve Your Model's Performance. In the previous lecture, we discussed how to handle missing values and outliers in Python. In this lecture, we'll discuss how to perform feature engineering to improve your model's performance. What is feature engineering? Feature engineering is the process of transforming raw data into features that are more informative and predictive for machine learning models. Feature engineering can be used to create new features, improve the quality of existing features, and reduce the dimensionality of the data. Why is feature engineering important? Feature engineering is important because it can significantly improve the performance of machine learning models. By carefully engineering your features, you can make it easier for your model to learn the relationships between the data and the target variable. How to perform feature engineering. There are a number of different techniques that can be used for feature engineering. Some common techniques include creating new features. This involves creating new features from existing features in your data. For example, you could create a new feature that is the ratio of the square footage to the number of bedrooms, transforming existing features. This involves transforming the existing features in your data to make them more informative or predictive. For example, you could log transform the square footage feature to make it more normally distributed. Reducing the dimensionality of the data. This involves reducing the number of features in your data without losing too much information. This can be done using techniques such as principal component analysis, PCA, and feature selection. Best practices. Here are some best practices for performing feature engineering. Use your domain knowledge to guide your feature engineering. Think about the relationships between the data and the target variable and create features that are relevant to those relationships. Experiment with different feature engineering techniques. There is no one-size-fits-all solution for feature engineering. Experiment with different techniques to see what works best for your data and your specific problem. Document your feature engineering steps. This will help you to understand your data and your model better, and it will also make it easier for others to reproduce your results. Real-world example, customer churn prediction. The real-world example that we'll be using is customer churn prediction. Customer churn is the process of losing customers. It's a major problem for businesses as it can be very expensive to acquire new customers. Dataset. The dataset we'll be using is a customer churn dataset. The dataset contains the following features: customer ID, customer name, customer type, customer tenure, monthly spend, number of support tickets opened, number of products purchased, and feature engineering. The first step is feature engineering is to identify the target variable. In this case, the target variable is customer churn. Next, we need to look at the features in the dataset and identify any potential problems with them. For example, the customer tenure feature is a categorical feature. We need to convert this feature to a numerical feature before we can use it in our model. To do this, we can use the pandas data frame method, and the pandas data frame method creates a new data frame with new columns for each category in the categorical feature. The following Python code shows how to convert the customer tenure feature to a numerical feature. Just essentially 2 lines of code. And then once we've converted the categorical features to numerical features, we can start creating new features. One new feature that we can create is a feature that creates the customer's average monthly spend. To do this, we can use the following simple line of Python code. Another new feature that we can create is a feature that represents the customer's support ticket engagement. To do this, we can use the following Python code. Model training and evaluation. Once we've created our new features, we can train and evaluate a machine learning model to predict customer churn. In this video, we'll use a logistic regression model. However, you can use any machine learning model that you like. The following Python code shows how to train and evaluate a logistic regression model to predict customer churn. And then essentially it's just splitting the training data set, creating the model, fitting the model to the actual data that we want, and then evaluating the output for accuracy. Conclusion. In this video, we showcased a real-world example of how to perform feature engineering in Python to improve the performance of a machine learning model. We learned how to convert categorical features to numerical features, create new features, and train and evaluate a machine learning model. Feature engineering is an important step in preparing your data for fine-tuning. By carefully engineering your features, you can make it easier for your model to learn and improve its performance.